Hello friends, in this video I'd like to solve the following problem from the Italian Mathematical Olympiad 1987. Problem number 1. We wish to show that this polynomial 3x to the 5th power plus 5 times x cubed minus 8 times x is divisible by 120 for every integer x. So my hints for this problem. One hint is optional. Factorize this polynomial. It's optional, but it simplifies calculations a little bit, and it's necessary to factorize 120, and then after factorization of 120, consider every power of every prime which divides 120 separately. So in other words, split this divisibility by 120 problem into smaller, easier problems of divisibility by smaller numbers. So give this problem a try and I will see you in a minute. Okay, so my solution, I will take my polynomial and I will factorize it a little bit. So let's see, we can factor out x, and we have 3x to the 4th power plus 5x squared minus 8. And we see the following fact, that 3 plus 5 minus 1 in fact is 0. So we might guess that we can write this polynomial in the following way: 3x to the 4th power minus 3x to the 2nd power plus 8 times x squared minus 8. And after doing that, we have 3x squared minus 1 plus 8 times x squared minus 1, and of course x squared minus 1 can be factored out. We can factor it out. And x squared minus 1, we might write it as x times x minus 1 times x plus 1 times 3x to the 2nd power plus 8. Okay, so, and let's also notice that 120, well, it's 8 times 15, and 8 times 15 is 8, it's 3 times 5 times 8. So instead of showing that our number is divisible by 120, it suffices to show that it is divisible by 3, divisible by 5, and divisible by 8. And that should be easier. So let's consider these divisibilities separately. So first part, divisibility by 3. Well, it's pretty easy looking at that number. Namely, we can use modular arithmetic, why not? So we have 3 easy cases. X can be either congruent to minus 1, or x can be congruent to 0, or x can be congruent to plus 1, modulo 3. Well, in every case, when x is congruent to minus 1, 0, and 1, in every time, one of these parentheses will be 0. When x is congruent to minus 1, the third parenthesis will be 0. When x is congruent to 0, this part will be congruent to 0. When x will be congruent to 1, the second parenthesis will be congruent to 1. So in every case, x times x minus 1 times x plus 1 is congruent to 0 modulo 3. So it was easy. Now, let's consider divisibility by 5. Divisibility by 5. So now we have 5 cases. X can be, or let's write it as follows for the brevity's sake. When x is congruent to 0 modulo 5, Again, in our factorization, we have x. So necessarily x is, there is nothing to be written really, but let's write it anyway. So this is congruent to 0 modulo 3. Okay. What happens when x is either congruent to plus or minus 1 modulo 5? Well, then x minus 1 times x plus 1 is congruent to 0. So our product will also be congruent to 0. And finally, if x is either congruent to plus or minus 2, then we need to look at the last parenthesis, namely 3x squared plus 8, and this is congruent to 3 times plus or minus 2 squared plus 8. Well, it's 12 plus 8, it's 20. Sorry, there should be 5 in these places. I made a typo. My bad. Okay, but 20 is obviously congruent to 0 modulo 5. So in every case, we have divisibility by 5. And finally, let's consider divisibility by 8. Well, here we will have additional cases. First of all, let's consider x congruent to either minus 1 or 0 or 1 modulo 8. Well, then x times x minus 1 times x plus 1 is congruent to 0 modulo 8. So our product is divisible. Well, what happens when x is congruent to 2 modulo 8? What happens then? Well, then we have the following: x minus 1, x plus 1, 3x plus 8. I will copy it, not to write it so many times. Okay, well, now this product is congruent to 2 times 1 times 3 times 3 times 2 squared is 12 plus 8, 20, and this is 40. This is 3 times 40. 40 is congruent to 0, so it's congruent to 0 modulo 8. Next case, congruent. If x is congruent to 3 modulo 8, then our expression is congruent to 3 times 2 times 4 times whatever. Doesn't really matter because here we have 8. So it's congruent to 0 modulo 8. Okay, how many cases are left? 3, 4, 5. 3 cases are left. X congruent to 4 modulo 8. If x is congruent to 4 modulo 8, then our product is congruent to 4 times 3 times 5 times, let's see, 4 squared is 16, 16 times, oh, let's write it like that. And now notice there that this last part is congruent to 0. So the entire product is also congruent to 0. Okay. So we have now considered 6 cases, 2 more. X congruent to 5 modulo 8. Well, then our product is congruent to 5 times 4 times 6 times whatever. Doesn't really matter because 4 times 6 is 24 and 24 is congruent to 0 modulo 8. And finally, do I have space left? Not really. So I will add a new page. Well, if x is congruent to 6 modulo 8, then our product is congruent to 6 times 5 times 7 times 3 times 6 squared is 36 plus 8. And now let's do the following to avoid tedious calculations. 6 is 2 times 3, 5 is 5, 7 is 7, and here we can factor out number 4. And we have 3 times 9 plus 2. And we see the following, that 2 times 4, it's 8. So this number is again congruent to 0 modulo 8. Every time we got the remainder 0, which is what we really wanted, to be honest, and we can write our final comment, since 3, 5, and 8 divide our sum, it must be also true that 120 divides our product. Let's no. And that closes our proof. So as you can see, this problem was not really hard. Modular arithmetic is extremely useful. And one more remark before you go. Well, this factorization of our polynomial was not really necessary, because the same line of reasoning would be sufficient without factorization. We would just put 0, 1, 2, 3, and so on into this polynomial, and every time we would get a number which is congruent to 0 modulo 3, 5, or 8. But after factorization, our calculations are a little bit easier, I'd say. Thank you for watching, and I will see you soon.